Good day, class. In this video, we're going to discuss lesson 3 under module number 3. This is all about continuous compounding, cash flow diagram, and inflation. Now, by the end of this lesson, you will be able to solve engineering economic problems related to continuous compounding. Now, by the way, continuous compounding is an example or another type of compound interest. Next is you will be able to solve engineering economic problems interest related to interest rates considering the effect of inflation. And finally, you will be able to construct cash flow diagram from a given engineering economic problem. Now let's start with the concept of continuous compounding. So continuous compounding occurs if the period of compounding is every day, every hour, or every minute, or approaches infinity. So again, since this is another type of compound interest, then the formula depends on the original formula of the compound interest rate, and that is to solve for the future worth, we use f equals p times 1 plus in over m raised to mt. Now, for the case of continuous compounding, our compounding scheme, which is m, approaches to infinity. So thereby, this original equation will reduce to f equals p times e. This one is the Euler's number raised to Rn, wherein our R here is the interest rate for continuous compounding, and n should be expressed in years. And the formula for solving the effective interest rate for continuous compounding is by using this equation. Now the question here is um, where does this um, or how is it being derived? Okay, how does this formula for continuous compounding being derived? This f equals p times e raised to Rn. So we're going to use the concept in your calculus. So again, for the derivation of this formula, let's start with the general formula for compound interest rate. So this is the formula in which our m for continuous compounding approaches infinity. Now for our derivation, the first step is we're going to let another parameter or variable n, and this one is equal to the ratio of m over in. So our in here stands for the nominal interest rate. Now, as m approaches infinity, so this equation, the n also approaches infinity, because from this equation, the relation of n and m are directly proportional. Next is we're going to substitute this variable n to our original equation. So the original equation will become this equation right here. So the difference for this one is that the expression in over m becomes 1 over n, and then the um, exponent becomes in times nt. Next is we're going to extract the uh, exponent. So we have for our inner expression inside this brace, we have 1 plus 1 over n raised to n, and we have an outer exponent of in times t. Next is we're going to apply a limit on both sides of the equation as n approaches infinity. So we have this expression, and take notice that the expression inside the brace is very familiar in your calculus subject, because in calculus this expression is equal to the Euler's number E. Now we're going to substitute this one to our expression. Therefore, by taking the limit on both sides of the equation, for the left side we have f, and for the right side we have b, and then this expression again is equal to the Euler's number and then raised to int. Now, this one is also popularly known as PERN. So you can memorize this formula by simply saying that the future words is equal to PERN. Next, let's proceed to cash flow diagram. So the cash flow diagram is a graphical representation of the transactions that are being made by a company or a certain firm, in which, as you can see, it comprises of this horizontal line, and within this horizontal line we have several scales from 0 up to n. So these scales denotes the number of years for the transaction, and the transactions, especially money, because we're dealing with money here, are represented by these arrows. So these arrows have distinct directions. So the arrow that points downward indicates an outflow of money. So that's cash out. And if the arrow points upward, it indicates an inflow of money. So we term that as cash in. Now the cash flow diagram, especially in constructing this one, depends on the point of view of the person involved in the transaction. Let's say, for example, you're going to deposit money uh, to the bank. So we have two point of views here. That is you as the depositor and the side of the bank. Now let's construct first the cash flow diagram on your point of view. So create a horizontal line, and within this horizontal line create a scale for the number of years, so from 0 to n. And let's say you deposit um, 100 pesos at the 0th year, so initially. So again, since you deposit money to the bank, so that is an outflow of money in your perspective or in your point of view. So the direction is downward. And let's say after 3 years, you deposit again 1,000. So again, an outflow of money. And next is you decided to withdraw 500 pesos in 5 years. So the withdrawal is an inflow of money in your point of view. So the direction here is upward. Now, in creating a cash flow diagram, do not forget to include the nominal interest rate for the transaction. So we have here 3% and also the compounding scheme. So here we have m equals to 1. It indicates that the compounding scheme is annually. Now we're going to convert this on into the bank's point of view. So for the bank's point of view, your 100 deposit at year 0 will be an inflow of money in the bank's point of view. So the direction is upward. And again, your 1,000 deposit on the third year will be an inflow of money the side of the bank, and your 500 peso withdrawal will serve as an outflow of money in the bank's point of view, and that is for the fifth year. And again, do not forget to include the nominal interest rate for this transaction as well as the compounding scheme. Next, let's proceed to the concept of inflation. So when we say inflation, this is the decline of the purchasing power of money and the increase in the price of goods and services. So this is an important indicator on the health of the economy of a certain country, because if we have a higher inflation rate, then it would be difficult for the people to buy goods and services. So most likely the economy will collapse, and then the purchasing power of our money, or the value of our money, um, is not the same as before, or the worth of our money is not the same as before, no, or uh, as it is used to. Okay, now, um, for this concept, we're going to use this formula in evaluating the magnitude of the effect of inflation to our money, or to our transaction. So we use this formula: F equals P times 1 plus I raised to N times 1 plus F raised to plus and minus N. Now, uh, the formula for the inflation has familiar expressions. So for the first expression, that is P times 1 plus I raised to N, this one is for the type of interest. So it could be simple interest or compound interest. And then the second expression, this one, 1 plus F raised to plus and minus N. So this is our inflation factor, because our F here stands for the inflation rate. Now, let's focus on to the exponent side of our inflation factor. We have here plus and minus n. The question is, when can we use the positive n, and when can we use the negative n? Now, we can use the negative n if the transaction is more on savings. Examples are if you invest or deposit money to a bank. So you use negative n. Now, you can only use positive n if the transaction is more on expenses. That is, you apply for a car loan or a house loan, or you buy some goods or services. Now, for the let's go back to the type of interest, which is the first expression in our formula. So again, uh, is either a simple interest. So for the simple interest, this expression will change into this one: P times 1 plus IN. So this is for simple. And if it is compound interest with a uh, with a distinct compounding scheme, so we're going to use this formula in which we have the nominal interest rate and the compounding scheme. Notice that our N here changes to the product of the compounding scheme and the time in years. Now the question is, if we're going to use this formula, does the N on the inflation factor will also change into MT? The answer is no. So for inflation factor, the N will stays the same no matter what the type of interest uh, is given. Okay, because again, the inflation rate is per year, not per semi-annual, not per month, or not per quarter. Okay, so n will remain as is no matter what the type of interest that is being involved in the problem. Okay, so here we have some sample problems for continuous compounding, creating cash flow diagram, and um, the last topic, that is inflation. Now let's answer this problem. So the problem states that if the nominal interest rate is 3%, how much is 5,000 worth in 10 years in a continuously compounded account? So the requirement here is the future worth of 5,000 at an interest rate of 3% in 10 years compounded continuously. So the solution is simply use the formula burn, then substitute the given values. So our principal or present worth is 5,000, our R is 3%, and then our N, which is expressed in years, is equal to 10. So simplifying this one, the future worth is 6,750, and that is letter A. Next, we have here a man wishes his son to receive 500,000 10 years from now. So what amount should he invest now if it will earn interest 12% compounded annually during the first 5 years and 15% compounded quarterly during the next 5 years? So from the problem, we have two compounding schemes that are involved. For the first 5 years, we have the annual compounding scheme, and the next 5 years is the quarterly compounding scheme. Now, in order to visualize the transaction that is being created in the problem, so it is best to construct a cash flow diagram on the point of view of the man. Okay, so again, we're going to create a horizontal line. So the scale ranges from 0 year up to 10 years, because again, from the problem, we have first 5 years and next 5 years, a total of 10 years. Next is we're going to plot the 500,000 pesos. So since this is the target of the man, that he will going to give this to his son 10 years from now. So again, uh, in his point of view, so this is um, an inflow of money, because again, uh, in order for him to give an amount of 100,000, so he need to withdraw this amount of money from a certain bank. So that's 500,000 pesos. Next is um, again, this is our requirement in which we're going to determine how much does he need to invest now so that he can um, produce 500,000 pesos after 10 years. Now, again, for the first 5 years, our nominal interest rate is 12%. The compounding scheme is annually. And for the next 5 years, the nominal interest rate is 15%. This is compounded quarterly. So our compounding scheme is equals to 4. Now, you cannot use the formula for the compound interest rate now in converting the future worth, which is equal to 500,000, to present worth. It's because we have two different compounding schemes that are being involved. So the best way to solve for this is to convert first the 500,000 pesos into its equivalent present worth uh, at the year 5. Now, so if we can uh, convert this one, this 100,000, to the present worth uh, on year 5, then this present worth is also equal to the future worth in this year. And by using this information, we can now solve for its equivalent present worth in the year 0. Okay, given the first compounding scheme. Okay, so again, by using the cash flow diagram, the first step is to solve first the equivalent present worth of the 500,000 on the year 5. So we're going to use the general formula for compound interest. Now we're going to modify this one to solve for P5. So P5 is equals to this expression. Now the T here is equals to 5 years, because this is the number of years between year 5 and year 10. Next step is to substitute the the given values of our parameters. So we have 500,000 for F10, and then for the nominal interest rate, we have 0.15, and the compounding scheme is 4. Now simplifying this one, our present worth of 500,000 in year 5 is equal to 239,446.17, and this is also equal to the future worth on this year. Next is we're going to use this information to solve for the present worth in year 0. So solving for PO, again, we're going to use the same equation. So this is the general equation for compound interest. Modifying this one to solve for P sub 0 or PO. Now the T here is the number of years between year 0 and year 5. So this is for the um, annual compounding scheme. So substituting the values, we have um, we have a present worth in year 0 equal to 135,868.19. So this is the amount of money that the man should deposit today in order to give 500,000 pesos to his son 10 years from now. So the answer is letter A. Next, uh, the problem states that you deposit 1,000 pesos into a 9% account today. So at the end of 2 years, you will deposit another 3,000. In 5 years, you plan a 4,000 purchase. So how much is left in the account 1 year after the purchase? Now, if you will met this statement 9% account today, so this is automatically um, an interest rate for an annual compounding scheme. So that is per year. Now, first things first, since the problem involves several transactions, so we're going to create cash flow diagram to map those transactions. So the point of view here is you as the depositor. So this is our horizontal line with a scale ranges from 0th year to year 6. So the first transaction is your 1,000 deposit, and it happens today, so that is uh, on year 0. So the direction is downward because that is an outflow of money in your perspective or in your point of view. Next is in after 2 years, so you deposit again 3,000 pesos, so the direction is downward, and then you decided to withdraw an amount of 4,000 in 5 years because you're going to use it to purchase something as stated in the problem. Next is uh, we are going to solve the um, for the amount of money that is left in your account 1 year after the purchase, so that is in 6 years. So again, the direction for the 4,000 withdrawal is upward because that is an inflow of money in your point of view. Now, in order to solve for F6, we need to we need to need to monitor the interest per year. Okay, so the first step is let's start at year 0. Okay, so we're going to monitor the amount of money that is accumulated in your account, and then we move from 0th year towards 6th year. So if it is deposit, so that is an additional money in your account. If you withdraw something, so we need to deduct the amount that you withdraw. Okay, so first is at year 0, so you deposit 1,000 pesos, and then after 2 years, of course, this 1,000 will grow at a certain interest. So we're going to solve again. I forgot to mention that in your CFD, you also need to indicate the nominal interest rate and the compounding scheme. Okay, so let's go back to our discussion on these figures. So again, we are going to solve the future worth of this 1,000 after 2 years. So That would be your F2. Next is we're going to add this one to your 3,000 deposit. So that's addition in order to determine the accumulated present worth on this year, and that is for the second year. Next is we're going to determine the future worth of this accumulated present worth in the second year, uh, in year 5. And since you withdraw 4,000, so the future worth of your P2, which is from here, you're going to deduct that one by 4,000. And after the deduction, so you have a net future worth on year 5. And then we're going to translate this one into its equivalent present worth for this year. So again, we're going to use this one to solve for the future worth on year 6. Okay, so let's start by solving the future worth of 1,000 pesos after 2 years. So we're going to use this formula for compound interest. Now the number of years involved here is the number of years from 0 to 2. That's 2 years. Okay, then plug in the values. So we have the future worth in the second year of 1,188.1. Next is we're going to solve for the accumulated present worth on the second year. That is the sum of F2 and your 3,000 deposit. So your accumulated present worth in year 2 is 4,188.1. Next is we're going to solve for the future worth of P2 in the 5th year. So we're going to use this formula. So the T here is the number of years from year 2 to year 5, and that is equal to 3, as you can see on the next line of our solution. So again, plug in the values for our variables. So you have the future worth of B2 in 5 years equal to 5,423.71. Next is we're going to get the net future worth on year 5, because again you withdraw 4,000, so we're going to subtract that one by 4,000. So you have a net future worth on year 5 that is equal to 1,423.71, and this value is also equal to your present worth on this year. Next, or the final step, is to solve for the future worth in 6 years. So by using this formula, so the T here is the time from year 5 to year 6, and that is equal to 1. So substituting again the values of our parameters. So we have the future worth in year 6 equal to 1,551.84. So this is the amount of money that is being left after several transactions. Therefore, the answer is letter C. Now, last problem, we have what is the future worth of my 100,000 pesos after 5 years if I invest today at a rate of 12% compounded annually. So the inflation rate is 8% per year. The next question, the second question, is what is the actual effective rate given to the account? Now, when we talk about the actual effective rate, so this is the effective rate that takes into consideration the given interest rate of 12% and the inflation rate of 8%. Now, first things first, we need to create a CFD. So the point of view here is me, myself. Okay. So at year 0, you deposit 100,000 pesos, or I deposit 100,000 pesos. So the first question is, what will be the future worth of this deposit? given that we have a nominal interest rate of 12% and the compounding scheme is annually, and that is equal to 1 for M. And then the inflation rate is 8% per year. Okay, so we have two requirements here: the future worth of this amount and the actual effective rate of the given account. So first, solving for F5. So we're going to use the formula for the inflation. That is a combination of the given interest rate and the inflation factor. Now, we have here plus and minus n. Now, the problem is more on investment, meaning more on savings. So therefore, for savings, we're going to use the negative n. So therefore, the inflation factor becomes 1 plus f raised to negative n. Notice on the type of interest, we change this one because this one is compound interest for annual compounding scheme. Okay, so the t here is equals to 5 years. So substitute the values of our given variables. So this is now the resulting equation. Therefore, the future worth of the 100,000 pesos, considering the effects of inflation, is 119,942.01. Next is we're going to solve for the actual effective interest rate given to this account. Now again, this concept is that this is the interest rate that takes into account the effects of um, the combined effects of the given interest rate, that is 12%, and the given inflation rate, and that is 8%. Now, how are we going to solve for this one? Now, the same concept with the original equation for effective interest rate, in which we're going to equate the future worth of the formula for the inflation and the future worth of the standard formula for compound interest rate. So again, on the left side of this equation, this is the formula for the interest rate considering the effects of inflation, and this one is the standard formula for the compound interest rate. So again, we just equate the formula for the futures. Again, for this equation, the present words will be cancelled out. So what's left is only this expression. So we're going to modify this formula as a function of the effective interest rate. So with several modifications, so the effective interest rate is equal to this expression. Now, after arriving this expression, next step is to substitute the values. Okay, so right here, so our t is equals to 5 because this transaction is good for 5 years. Therefore, the effective interest rate is approximately equal to 0.037, or in percent that is expressed as 3.7%. Okay, so that's it for this lesson. I hope you learned something. So thank you and God bless.